Okay, good morning and welcome to this other video. And today, what I would like to discuss is that today there is a big discussion about global warming and the fact that this is very dangerous and also, for instance, there is a big discussion about CO2 and how carbon dioxide is actually increasing the greenhouse effect and how this is this is very dangerous for the environment and for everybody actually. But there are some points actually that are not really discussed. And for example, why uh, like for instance, global warming actually is could be extremely dangerous, and this is the topic that I would like to discuss in this video, and this has to do with the oceans actually. So if you think that in the I mean on the earth there is a huge amount of water, and mostly this water is in the oceans. Okay, and now let's draw a little bit here. So this is like some mountains here, and then here we have the water, and here we have actually some fishes here. Okay, so this is the water in the oceans. Okay, so how big is the amount of water on earth? And this would be 1.3 billion cubic kilometer. So 1.3 billion kilometer, and this would be equivalent to 1.338 to be more precise, and then millions here, billion, and this would be cubic meter of water into the oceans. Okay, so we have this amount here of water into the oceans, and then we have the atmosphere here. So here we have some birds, for example, and here we have the atmosphere. And how big is the volume here? It would be almost, it's comparable to the volume of water, and this would be 1.4 billion cubic kilometer, like in volume. So this would account for 1,4,0,0,0, and then billion here, and this would be cubic meter for the atmosphere here. Okay, now let's um, let's talk about CO2 content into the atmosphere. Let's talk about CO2 content into the atmosphere. So basically nowadays we have an amount of CO2. So it's the CO2 in atmosphere is 407.4 parts per million. Okay, so this would be equivalent to 1 milliliter on 1 cubic meter. Okay, so this is the equivalent in part per million. Okay, so this is the more or less the concentration of CO2 into the atmosphere today. To be toxic, the concentration of CO2 into the atmosphere should be 5,000 p part per million. Okay, now if we do 5,000 minus 407.4, this would be equivalent to 5,593 part per million, and this amount would be the amount of CO2 required to, if we give this amount to the atmosphere, then we would be like in big trouble because the concentration of CO2 into the atmosphere would be toxic, and therefore this is very dangerous. Okay, so let's assume that we have to give to the atmosphere this concentration. In the worst case scenario, it will happen that this concentration will be released to the atmosphere in a way or in another. Now, let's go back to this slide. We have seen that here we have the water into the oceans. Here we have the CO2 here. We have some CO2 concentration here. And then what is happening is that there is an equilibrium between the CO2 concentration into the atmosphere and the CO2 concentration into the water. Into the water. So this already gives you an idea that in the water of the oceans there is a big amount of CO2 here. Now let's take into consideration more into detail what are actually the reactions that are happening in water. So now if we take the land or the oceans and everywhere, there is a huge concentration of limestone. So this is a very common white rock that we can find everywhere in the world. It's extremely common to have this limestone like everywhere. And what is happening is that this limestone is actually dissolving. So CaCO3, it releases Ca ions plus CO3 2 minus ions. Okay, now what is happening in the water is also other kinds of reactions, and for example H2O is in equilibrium with H plus OH minus, and also this CO3 O3 2 minus plus H plus, this would be in equilibrium with this other product here, with the carbonic acid. Okay, and then the carbonic acid is actually HCO3 minus plus H plus. Okay, this would give, so let's write it here, this would give CO2 plus H2O. So you see that at the end of the day, all this equilibrium here can be shifted can be shifted in the direction that CO2 actually is produced. So, and without going into really detail here, because I want to be very simple here, without to go into the detail, if we have an increase of temperature of water, so now this is very important. If we have an increase of temperature, so the temperature goes up, and then this limestone dissolution is faster, faster, and because of this reason, then we have more release of CO2. Because let's assume that, for example, the concentration in water of CO2 it's very big, it's very large, then this CO2 here will start to go into the atmosphere. Okay, and therefore the concentration of CO2 into the atmosphere will go up. Okay, so now let's have an idea of how much limestone would be actually necessary to be dissolved to give us the equivalent needed needed for reaching the toxic concentration of CO2. Okay, so let's do some calculation. Then 1 mole of gas at 1 atmosphere and 25 degrees Celsius is equivalent to 22.4 liters. Okay, and 1 part per million is equivalent to 1 cubic centimeter. 1 cubic centimeter. Okay, so then we do that in 1 cubic centimeter, how many moles are contained, and this will be equal to 1 divided by 22.4 times 1000. This is equal to 0.0004464 mole. Okay, and then the molecular weight of CO2 is 44.1 grams on mole. So this would be times 44.01 grams on mole. So you see this mole goes away with this other mole, and then we obtain grams here. Okay, so 1 cubic centimeter, 1 part per million of CO2 is equivalent 1 ppm CO2 is equivalent to 0.001965 grams of CO2. Okay. Now, if we we said that we need 4,593 ppm, okay, of CO2 to reach the toxic concentration. Then the grams required in total into the atmosphere, I mean per cubic meter, we would need this amount here, times this amount here. So this times 0.001965 grams would give, so this would be grams on ppm, So this would give us grams, and this is equivalent to 9 grams, 0.2 grams on cubic meter. Okay, so this would give, if we multiply this value here, if we multiply this value times the total amount of the volume, so the volume of atmosphere, so this is billion cubic kilometer. This is the volume of the atmosphere, and if we multiply 9.02 grams times 1.4 billion cubic kilometer. Okay, so we have to convert this in meters actually. Anyway, this will give you 1.26 times 10 to the power of 19 grams. So this amount, 1.3 times 10 to the power of 19 grams are needed of CO2 are needed into the atmosphere to reach a toxic concentration. And this would be equivalent more or less, this is more or less equivalent to 10 to the power of 13 tons of CO2. Okay. Of CO2. Okay. Yes. Now, if we consider the molecular weight of the molecular weight of CO2 is 44.01 grams on mole, and the molecular weight of CaCO3 is equal to 100.0869 grams on mole. So at the end of the day, we need to dissolve so dissolve around 200,000 ton of CaCO3. So this is the amount we need to dissolve in order to have that concentration of CO2 into the atmosphere. And now if we consider the density of limestone, this would be 2,160 kilograms on cubic meter. So 200,000 kilogram divided by 2,160 kilogram on cubic meter. This gives you 92,592.6 cubic meter of rock. So this is like the volume of rocks to be dissolved, okay, to be dissolved. Now, because at the end of the day, these are numbers, and to have an idea of actually how small is this amount, you have to consider that the Great Pyramid of Giza in Egypt, okay, this would be 2,583,283 cubic meter. So 2 million cubic meter is the Great Pyramid of Giza, okay? And if we compare that we need only 92,000 cubic meter of limestone to be dissolved in water into the oceans to give a concentration of CO2, if this would be released all into the atmosphere, this is quite a small number. This is a very small number, because if we divide this number here, so if we divide this number here by 92,592.6 cubic meter, so this is our amount, the amount that is required, or let's say if we dissolve this amount and then we release all the CO2 produced into the atmosphere, we will have a toxic concentration of CO2, and actually this value here is 28 times less than the Giza pyramid, okay? So you see that actually, so from this video, now I don't know, I got this data, I didn't search in very detail the numbers here, but then I mean you can consider an approximation here. So if you consider an increase of temperature into the atmosphere, so the so-called global warming, and then you think that this temperature, this increase of temperature would increase the temperature of the water. Okay, so let's assume that the water is increasing its temperature, then the limestone that is contained into the water is actually dissolving more, and then how much limestone actually we need to dissolve in order to raise the concentration of CO2 into the atmosphere to a toxic concentration is actually the equivalent of 28 times less the Pyramid of Giza in Egypt. Okay, so with this I have finished here these comments, and see you next time.